Okay, let's go now for the eBGP lab. In this case, we're going to configure an eBGP session between these two routers, an eBGP session between these two routers. It is going to be eBGP or external BGP session because these two routers have this autonomous system number 65001, and this router internet one has this autonomous system number 65000. In this case, given these two autonomous system numbers are different, these become an external BGP session. The same happens with RB1 and Internet 1 and RB2 and Internet 1. We are also going to set up eBGP here because these RB1 and RB2 routers have this autonomous system number and Internet 1 has this autonomous system number. These numbers are different, so this becomes an external BGP session. Notice that we're using multi-homing because we have two separate connections in order to have high availability. And we are going to use the VRF internet here, 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 and here. And the corporate routers will have an address family for IPv4 and an address family for IPv6 within the VRF internet in order to set up these BGP sessions. However, at the Internet 1 router, we are going to configure BGP at the global routing table. So the Internet 1 router is unaware that we are using a VRF on the other side. We are also going to configure an iBGP session between Internet 2 and Internet 1. This is an iBGP session or internal BGP because these two routers belong to the same autonomous system number. We are going to connect this router to the internet. We are going to acquire through DHCP a default route for IPv6 and a default route for IPv4. We are going to inject those prefixes using the network command here at this router. So this prefix will be advertised through BGP, and these prefixes will land at router A1, router A2, router B1, and router B2. So within the VRF internet, we are going to receive for IPv4 the prefix 0.0.0.0/0, and for IPv6 the prefix 0:0/0, which is the default route for IPv6. We are also going to configure here port address translation. So we are going to provide these prefixes, these prefixes, these prefixes, and these prefixes access to the internet using port address translation. So let's go for the lab. So let's configure router A1, A2, B1, and B2. Notice that we already have in this all of these routers already configured the VRF internet that has support for IPv4 and IPv6. So the configuration for BGP will be actually pretty simple. We are going to use our autonomous system number that we were assigned, and then for each neighbor we are going to place these neighbors on separate address families. The neighbor for the address family IPv4 VRF internet and the neighbor for the address family IPv6 for VRF internet. Notice that we are going to configure the address on the other side that belongs to the neighbor and the autonomous system number that belongs to the neighbor using remote as. So if we wanted to validate that, we could issue show IP BGP BPMB4 VRF internet summary. We will see that the neighborship is still in idle mode. We will need this to go into established mode. It is still in idle mode because we have not configured the other side. So let's configure first a router A2, router B1, and router B2, and then we're going to go for the router internet 1. So remember that the first line establishes to what autonomous system number this router belongs to, and this router, and then these lines are going to establish what is the configuration of the remote neighbor. So let's go for router B1. Notice that given we are configuring now this router B1 or router B2, they belong to a different autonomous system number, in this case 65002. So in this case, router B1 belongs to this autonomous system number, and we are just configuring the IP address and remote autonomous system number that belong to the router on the other side. So let's go for router B2. Okay, now let's configure Internet 1. Notice that it already has the required IPv6 and IPv4 addresses. Remember that in this case, this router belongs to another autonomous system number, which is 65000, and this will be the neighborships. This will be IPv4 for router A1, IPv6 for router A1, IPv4 for router B2, IPv6, I'm sorry, IPv4 for router A2, IPv6 for router A2, and so on. So let's see how it goes here. Now, when it goes to establish, then this field becomes change its meaning, and if we see a number here, it is a good sign. This means that we are already in established state, so we can issue the same. We see a number, that is a good thing. We see a number, this is a good thing. And let's see here, we see a number, so we can issue also here. In this case, we are using this command because we are configuring BGP in a particular BRF, and here we're using a global routing table, so we can just go and issue show IP BGP summary. We see a number that is correct. Now let's go for the second part. We're going to configure eBGP between router Internet 1 and router Internet 2. So let's open here console. So let's configure here. These routers also belong to this autonomous system. Notice that this is an eBGP or internal BGP session because the neighbor has the same autonomous number as the local router. So we can issue show IP BGP summary. It is idle because we need to do set up the iBGP session on the other router. Let's do that. So let's go here and go for router BGP. So we could go here and issue this. We see a number, which is good. Let's see now our routing table. We don't have a default route, so let's try to delete this interface gigabit 20, which goes to Ethernet 2, and let's relink it gigabit 2 to Ethernet 2. Let's just see if we can get an IP address. Let's see. We're using DHCP here. DHCP. We should receive here a DHCP IP address. Okay, after a few resets, we received an IP address from our internet switch. So we have this public IP address, and we have this network now. So we need to inject this into BGP. So we are going to use a network command. So let's go to router BGP 6500 and issue network 0.00 mask 0.00. Now internet 1 should have it now. And let's see if we have it now here. Show IP route VRF internet. We should receive that. There is an issue here. There should be this code here, which is best. It must be because we don't know this next hop within our network. So this is our little issue with eBGP. So let's change this configuration a bit. We are going to modify a default behavior of eBGP. So let's go for router BGP. And let's change the next hop. So for 189.3.1, we're going to say that we are going to be ourselves. eBGP doesn't change the next hop, so we are making it change it. So let's clear our BGP sessions. And then let's wait until it comes up. Let's see. We added this line here. Let's see, we have still this, we have the default route. Network 00. Okay, now we have the default route here. Now the next hop is exists now in the routing table, so now we can place this route. Now we should be able to have this default route in the BRF users. Now if we pinged the internet, we don't have access because we are trying to reach it through this particular IP address. So we need to NAT this. Let's do a little NAT here. And then we have interfaces gigabit 2 and gigabit 5. So I'm going to do a little NAT here. So Not outside, not inside. Okay, seems good. Seems good, seems good. No translations. Let me see if we issue source IP address. Oh, I'm sorry. I have to use the BRF internet. Ping BRF internet. I should see something here. We should be able to ping it here. So now we are NATing from here to here. Oh yeah, I need to advertise this. This particular router does not have to route back the prefixes 189 whatever, so we are going to include them here. We still need to advertise some prefixes into the BGP network. So for instance, router BGP, we are going to issue network 199.1.1 on 11 mask. That should make it work. Okay. Now this guy knows where to route back this prefix. We should do the same with all the prefixes. We are advertising this prefix, this prefix, this prefix, and this prefix through BGP. So now this guy here knows them. Now they can route back the packet. So ping BRF internet 8888 successful. So now we can ping the internet from our routers. So let's see how the commands shows the routing. So in order to see the BGP RIB on the global routing table, we issue show IP BGP. So this router internet 2 knows these prefixes through eBGP, and these prefixes are IGPs because these prefixes were injected through network command. So when you inject a prefix into BGP that is using the network command, we are going to show this I as I. Otherwise, if you use the redistribute command, you will see this as a question mark. Now, this I here exists because we have an eBGP session between Internet 2 and Internet 1. That is the reason for that either. So this is an I for eBGP, and this is an I coming from that indicates that this prefix comes from the network command. So notice that most of the time the local preference doesn't show up. If you don't see a local preference, it is usually 100, which is the default. For local injected routes, notice that this is local, this is local, this is local, this is local, because we injected that through the network command. The next hop is 0.0.0.0. This indicates that the next hop for this prefix is this router. So 0.0.0.0 indicates myself, in this case Internet 1 router. So in order to see that using a BRF, we could issue show IP, BGP, BPMB4, BRF Internet. So we are taking a look into this particular reef that belongs to the BRF, because BGP can have several reefs. One reef for the global routing table, and reefs, separate reefs for each BRF. So in this case, we're taking a look at the BGP reef that belongs to BRF Internet using this long command show IP, BGP, VPN, B4, BRF Internet. Compare that with the global routing table, which is just show IP, BGP. So show IP, BGP for the global routing table. Show IP, BGP, VPN, B4, BRF, and the name of the BRF for particular BRFs. Notice that this, for instance, this is the default route. They all come from the network command. Remember that. We injected the default route using this command. We need the default route to exist in the global routing table. So we know it exists. So if this route didn't exist here, it wouldn't exist here. It wouldn't be injected. So given it exists, it is injected. And we inject this from the reef into the BGP reef using the network command. This is the reef. This is the routing interface, routing information base, and this is the BGP routing information base. This is the reef, and this is the BGP reef. Now we injected this particular prefix from the reef into the BGP reef using the network command. Now we did the same here. This is the reef. And this is the BGP reef. This is the reef. This is the BGP reef. Now we injected these four items, these four prefixes, using network commands. And this is why we see an I here. Now let's say that we didn't do that. Let's use another way to inject these prefixes. So we are going to use a different command to inject these prefixes into the BGP reef using redistribute connected. Now notice how we had eyes here for these two prefixes. Now if we issue the same command, we see this symbol because I used the redistribute command. So using the network command, using the redistribute command, using the network command, using the redistribute command. So in this way you can tell whether a prefix was injected into BGP using the network command or the redistribution command. And do not confuse this I with this I. This I means that this prefix was learned through eBGP, and this I here means that this prefix was injected into BGP using the network command. Okay, we still have access to the internet here. And if we issue show IP route BRF internet, this is the way to see these BRF reefs, and this is the way to see this BRF BGP reef. This is the BRF reef. This is the BRF BGP reef. A little bit different. This is the BRF reef. This is the BGP BRF reef. You can gather more detail. For instance, if you provide the particular prefix, you can see more detail about the prefix. This is a summary of prefixes, and this is detail for the prefix. Notice that for eBGP learned prefixes, we are going to see the as path here. This as path here is quite short because this prefix has only been advertised by one single autonomous system, which is 65000. That's it.